Welcome to part 3 Industrial Structures Roof Truss Design. In the last session, we created a model and section properties. In this example, in this exercise, we will go for load generation, analysis and design, and find out the best suitable sections over here. So if you can able to do the 3D rendering for this particular truss element, most of the sections we have actually assigned as a pipe sections, which is widely used for industrial structures, and it is very economical, and there are many advantages over other sections because of the symmetrical properties. Now let's go to the support. In the support, we'll create the bottommost nodes as a pin support assigned. So if you go to the isometric view, all the bottommost supports has been assigned as a pin support. Now go to the load definition. So what we can do just for a as we discussed in the earlier example as well, the wind load generation need to be calculated as per the wind load code. There is a specific calculations and applied to for the equations to get the wind pressure, and that wind pressure need to be applied for the structure. Okay, but however here we can assume as a 1 kilonewton as a joint support for the example problem, and later we can go for detailed calculations of the wind load calculations. Okay, so right now I will go add button over here. In the primary load case, we can make it as a load, and then I will make it as a nodal load, as in y direction is minus 2 kilonewtons added. So right now I'm going to select all the top nodes by making a front view. I'll go to the nodal cursor. This is the 1, this is 2, and then the topmost. If you go to the isometric view, you see all the top nodes has been selected. Now one thing, you select the 2 kilonewtons and you go over here, make sure that assign to the selected nodes, and then assign the loads has been. So you can, the scale factor can be used to reduce the point loads. Okay, you can also view the load value by applying here. So the loads has been applied right now. So once the load has been done, the next part is analysis. Okay, now the analysis, actually we have a very different types of analysis options over here. One is the perform analysis and P delta, perform cable analysis, non-linear, pushover analysis, and imperfection analysis, buckling analysis. So that means every analysis have their own advantages. Let's say for buckling analysis, it actually will estimate, when you do the analysis, we can able to find out the failure loads and also maximum load where the different modes of failures will occur. So each mode of the failure will provide the factored loads, where we can able to identify which load up to maximum what load it will take before it goes to the failure modes. So there are many advantages are there. So we can even refer the books published by Bentley, or even we can for advanced advanced trainings, we can even consult the Bentley systems itself to achieve more in detail knowledge on those areas. Okay, we'll go for the perform analysis right now. Once you have done, so the perform analysis has been performed. Go to analysis option. Once you do the analysis, so it has been done all the analysis options. And now if you go to the steel design, post processing, where we can see the beam stresses and all those things. So this is the first way what we have done in this example. All the elements we consider as a fully fixed connections, like as a welded connections, and that's why we never define this any member as a truss member. Rather, we treated all the elements as the beam element. Okay, and consider everything has been welded over here. So now the analysis has been performed, and actually you can see the forces, bending moment, and all these criteria in the graphically as well as in the uh, tables. However, all the information is already available in the ANL file as well. If you want, you can print the data over there. But in this exercise, in part 4, we will see the design options. Okay, thank you.